So we need to implement this full adder using NAND gate. So we can take the reference of this diagram, half adder and half adder. So this half adder is consisting of one XOR gate and one AND gate, and this half adder is also consisting of one XOR gate and one AND gate. Okay, so I will implement first this half adder. So how to implement this half adder? So I will implement the XOR gate which is present in that half adder. So I will implement this XOR gate using only NAND gate. Okay, so this is my XOR gate using only NAND gate, and from here I'm going to get my output. So this is nothing but my A XOR with B. So this is my sum of my first half adder. So this sum I'm going to give it to the second half adder. Okay. So second half adder also it is going to contain the XOR gate, right? So first I will implement that. So NAND gate. Now one of the input of this NAND gate is given this one. So this is one of the input, and another input is seen. Okay. So another input is seen we are giving here. So this is nothing but sum, which is nothing but A XOR B XOR C. Seen. Seen. Now, from where we are going to get our carry, from which gate should I take? What is the method which I should follow for taking out the carry? Can anyone tell me? From where can I get the carry? And for implementing my sum, I need 1, 2, 3, 4, 5, 6, 7, 8. 8 NAND gates I need for implementing my sum equation. Now, from where I should get my carry? How I am going to implement my carry? Any idea, anyone? So, what is my carry equation? Which I know carry is nothing but AB plus Cin into A XOR with B. Okay, AB plus Cin into A XOR B is my equation of carry. So where I will get my AB? So here I am getting my AB bar. Okay, so I am going to take this point. This is my AB bar, and here at this particular point of VC, I am going to get AX or B and Cn. So here the equation is Cn into AX or B the whole bar. So I can take this point. So I will make some modifications, and I'm going to give it to my NAND gate. Okay. So here I'm going to get it. So the equation which I'm getting here is I'm going to get is AB into Cn into A XOR with B, Cn into A XOR with B whole bar, and here also bar followed by whole bar. Okay, so this is the equation I'm getting at the ninth NAND gate. So this is the output from my ninth NAND gate. Output of ninth NAND gate. So if I solve this, what is that I am going to get? That is nothing but if I solve this, the equation of carry I am going to get. What is the equation of carry? AB plus Cn into A XOR with B. So this is how I am going to get my carry from this equation, from this circuit. Yes. So is this clear for everyone? Any doubts or any queries in this? Okay. For implementing a full adder using only NOR gates, again we are going to follow the same method. So first I am going to implement my NOR gates. So I will take the same expression. So this is my NOR gate. This is B, A, B, and from here I am going to get. And did we implement your half adder using only NOR gates? Have we done that? Yeah. So this is NOR, and from here I am going to take one more XOR gate, NOR gate. So this I am going to give it here, and Cn I am going to give it to here. Yes, and this I am going to give it to this NOR gate, and this I am going to give it to this NOR gate. So this is my sum. I've got my sum. Now, from where should I get my carry? Can anyone tell me? So you can take your output from here and one more output from at this point. So here we can give it to one more NOR gate. We are going to get carry. Okay. Is it clear for everyone? So a half subtractor, it is a circuit. So let me first draw the block diagram of this half subtractor, which has only two inputs A and B, and it has two outputs. One is difference and another is borrow. Okay. So this is our half subtractor. Now coming to the truth table of this half subtractor. So these are our inputs A, B, difference and borrow. So what are the combinations we have? 0 0, 0 1, 1 0, 1 1. Now quickly tell me the what are the values of difference and borrow for each and every case. So 0 0, difference is 0 and borrow is 0. Now 0 1, what is difference and what is borrow? For 0 1, what is difference and what is borrow? Quickly tell me. 1 1. So difference is 1 and borrow is 1. And here the difference is 1 and borrow is 0. Now in this case, what is the difference and what is the borrow? Okay. Yes. Now what is the equation for output diff? So diff is equal to A XOR with B. And what is the equation for borrow? Borrow is nothing but A bar B. Okay. So these are the equations for your difference and borrow. And if you draw the logic diagram of this, so it will look like this. So A, B given to an XOR gate, A, B, A XOR B is your difference. Okay. And A bar B, A bar into B is your borrow. A bar B is nothing but your borrow. So this is our half subtractor. And what is the width of A and what is the width of B? 1 and 1. Exactly. Yes. So this was about your half subtractor. Now let us see about your full subtractor. So let us see about your full subtractor. Now in the case of full subtractor, this is your block diagram of your full subtractor, where you have three inputs A, B and B in initial borrow in, and you have outputs as your difference and borrow out, B out. Okay. Now let me draw the truth table. A, B, B in and difference and borrow out, B out. Okay. So how many combinations we will have? 8 combinations. 0 0 0. So these are all the combinations which we have. Now what is the difference in the first case and what is the borrow in the first case? So difference is 0 and borrow is 0. Now what is the difference and borrow in the second case? For 0 0 1. For 0 0 1, what is the difference and what is the borrow? And in the second case, what is the difference and what is the borrow? And this case 0 1 1, what is the borrow and what is the difference? Now here 1 0. Now here, and what is the difference and borrow in the last case? So these are our differences and these are our borrows. Okay. Now what is the output of your what is your difference? Difference is nothing but sigma m. What you are getting? 1 2 4 7. 1 2 4 7. And what is your borrow which you are getting? Which is nothing but sigma m 1 2 3 7. 1 2 3 7. Right? Am I right? Is the borrow and difference equations, are they correct? Please let me know. Now, so we know 1 2 4 7, already we have seen in our full adder. Same minterms we are getting in our full adder also. Okay, that is nothing but A XOR B XOR B in. Okay, this is our equation for our difference. And what is the equation for borrow? So you can just simply draw, first of all write the equation. So equation for your borrow is nothing but A bar B bar C plus A bar B C bar plus A bar B C plus A B C, or else you can draw the K map for this. A B C, B bar C bar, B bar C, B C, B C bar, A bar and A, 0 1 3 2 4 5 7 6. So what are 1 2 3 7, 1 2 3 7. Okay, so let me group them. So what is the equation I'm getting? A bar C plus BC plus A bar B. So this is the equation for my borrow. A bar C plus BC plus A bar C plus BC plus A bar B, no? A bar B. A bar C plus BC plus A bar. This is the equation for my borrow. Everyone getting the equation, same equation? Yes. Okay. Now, what is the alternate equation for the borrow? Like we have alternate equation for sum as AB plus C in into AX or B. Can we get any alternate equation here also? Try to find out the alternate equation here also. This is B. Okay, this is B in. I've written C, but this is B in. Okay, so I will show you. So the alternate equation which I can get, so I will write down the equation again. A bar B bar B in plus this equation I can write AB B in, AB B in plus A bar B B in bar, A bar B B in bar plus A bar B B in, A bar B B in. Now if I solve this, if I take B in common here, then I am going to get B in into A X NOR with B plus if I take B common here in these two terms, B into A bar B in bar plus A bar B in. Okay, and if I solve this further, B in into A X NOR with B plus B into, if I take A bar common, then B in will be cancelled. Okay, so I'm going to get A bar. Okay, so finally I'm going to get the equation for another equation for carry as, let me write it with another pen. So the equation for carry, sorry, the equation for borrow out, B out as A bar B plus B in into A X NOR with B. So this is the alternate equation which I am getting for my borrow out. Okay. So how to implement this using your logic gates? So let us implement this. So this is your XOR gate A B C, A B B in, and we are going to get our difference, that is nothing but A XOR B XOR B in. Okay, and what about the carry? Carry, you can take this or you can consider this one also. Where is this? A bar B in plus B B in plus A bar B. Okay, so A bar B plus B B in plus A bar B in, A bar B in. Yes, so this is how we are going to implement our full subtractor. Okay, now let us try to implement this full subtractor using only NAND gates, and let us try to implement this full subtractor using only NOR gates. Okay, so how to implement this full sub? Now first of all, how to implement this full subtractor using only half subtractor? I can take my two half subtractors. This is my half subtractor, and this is another half subtractor. Okay, So here I am going to connect A and here I am going to connect B. Okay. Here I am going to get my difference, that is nothing but A XOR B. I am going to give it to my second half subtractor. This is A of my second half subtractor, and B I am going to connect it with my B in. Okay. So this B in I am going to connect it here. Okay. So here I am going to get my difference, which is nothing but A XOR B XOR B in. So this is the difference I am getting. Now coming to borrow. So coming to this borrow. So this is nothing but A XOR with B. This is A XOR B, right? So this is A XOR with B whole bar into B in. So this is A XOR with B into B in. And what else we want? The second equation we can take. So A XOR B, the whole bar is nothing but A X NOR B. Okay, A XOR with B, A XOR with B into B in, and we want A bar B. This is A bar B is nothing but borrow of first half adder, borrow of first half subtractor, and this is borrow of our second half subtractor. Okay, and I'm making OR operation. So that is what I'm going to connect here. So this is my second half subtractor borrow, and this is my first half subtractor borrow. So I'm going to make them OR operation, and I'm going to get B out. So this is how I'm going to implement my full subtractor using half subtractor. Yes, is it clear? Yes. So from the equation only we can determine. From the equation only we can determine what type of circuit we can take. Basically this A bar B is the borrow of the first half subtractor, and this second term which we are having, this is the borrow of the second half subtractor, and we are making OR operation. So from this equation only I am determining what is the structure of the circuit I am having. Okay. So yeah. Next. So let us try to implement your half subtractor using only NAND gates. Okay, half subtractor using only NAND gates. Now, how to implement your half subtractor using only NAND gates? You can again take this reference, this two half subtractors. So how to implement this is half subtractor, right? So you can take the reference of this diagram. So using half subtractor, what we have implemented, this XOR gate and one simple AND gate. So I'm going to implement first AND gate using only NAND gates. So how to implement this? So this is my NAND gate. This is A, B. This is one more AND gate here, followed by one more AND gate. I'm going to connect them, and here I'm going to connect this two to this one. So this is my NAND gate. Okay. So this equation is nothing but difference. Difference is excuse me. So difference is equal to A XOR B. Okay. Now I want A bar B. Now I want A bar B. So from where I'm going to get my A bar B? So from where can I get my A bar B? So if we observe here at this output, if we observe what is the equation which we are going to get is this is A B bar and this is B. Okay. So here we are going to get B dot A B bar the whole bar. Okay. So this is the equation we are getting. So if I try to solve this, B into A B bar whole bar. If I solve this, what I am getting? B bar plus AB. Okay. So that is nothing but if I apply distributive law, it is going to become A plus B bar. It is going to become A plus B bar. But what I need AB bar, right? So what I am going to do is I am going to apply it to one more, which is acting as a NOT gate. Okay, so that this whole bar will be removed. So let's see what is happening. So B into A B bar. Okay, so that means it will become B into it will become a bar into b plus 0. So this is our final equation. So this we are not taking. So what we are doing, we are taking one more NAND gate which is acting as a NOR gate. So this equation, if we remove this complement, then we will get your a bar into b. So this is how we are going to implement our half subtractor using only NAND gates. So is this equation clear? Now how to implement this half subtractor using only NOR gates? So first of all, we will implement our XOR gate. So this is our NOR gate. So this is our difference. Okay, from here we are going to get our difference, which is nothing but A XOR with B. Okay. Now, so from where we are going to get our carry is the main borrow is the main question. Okay. So let us see where we can get our borrow. So borrow equation is nothing but A bar B is the borrow equation. So we need to get this A bar B. So what can we do is, this is nothing but A plus B whole bar. Okay. And if we see this point is nothing but, this is A and this is A plus B the whole bar. So at this particular point, if I write the equation, so it is nothing but A plus B the whole bar, okay. If I solve this, then what I'm going to get is a plus b the whole bar can be written as a bar dot b bar, a bar dot b bar the whole bar. Okay. So if I apply this bar over here, so it is nothing but a bar into a bar dot b bar the whole bar. Okay. So or else what can I do? Okay, without writing this, let me erase this. So I can write this equation as a plus a bar dot b bar the whole bar, can I can write this equation as, I can apply distributive law here. So a plus a bar into a plus b bar the whole bar. Okay. So that is nothing but a plus b bar the whole bar. So if I apply De Morgan's law again, I'm going to get a bar b. So at this particular point, I will get the borrow directly. This is my borrow. So I can get that borrow directly from without applying any gate. Okay. So at this particular point, I will get the borrow. Yes. So let us see how to implement your full subtractor using NAND gates and NOR gates. Sorry, yeah, full subtractor, only NAND gates. So I will show the circuit for NAND gates. It will be the same circuit using NOR gates also. Okay. So first I will show the circuit for your full subtractor using only NAND gates. So how to take, again you can consider the same diagram. This is one half subtractor, this is one more half subtractor. First implement this two half subtractors using XOR gates. So that is, it is going to look like this. So this is one XOR gate, one NAND gate. You can connect to this. Okay. So this is one difference, A XOR B. This is A and this is B. Okay. And again we can take one more XOR gate over here, and here we are going to get A XOR B XOR B in. This is our difference. So here I am going to take my B in, and this B in I am going to connect it over here, and this A XOR B I am going to give it to here. Okay. So this is my difference. Okay. Now my question is, from where I am going to get my borrow. Okay. So I will give you the connection. You should prove me whether I am getting correct or not. Okay. So I will get correct only. So you can take this point and you can take this point. Okay. So these 2 points, take them and connect it to one NAND gate. So here we are going to get a borrow. Okay. So here we are going to get our borrow. So how I am deciding these points, you can refer the diagram for this. So what is the diagram? So in this diagram we can see we are taking the carry of the first half subtractor, and we are taking the carry of the second half subtractor, and we are making OR operation of this. So same thing I'm doing here. So So in the NAND gate, from where we are getting the carry, from this particular point, we are getting the carry, right? So that is what I'm taking. So from this point, I'm taking the carry. So this point, I'm taking the carry, and from this point, I'm taking the carry, and I'm giving it to an AND gate. So that is nothing but my borrow. Okay. So you can take the equations and you can solve them if you want. So this is nothing but AB bar, and this is B. So this is nothing but B into AB bar whole bar. Okay, you can solve them, and this is nothing but A XOR B into B in bar, and this is nothing but B in. So output will we will get, and make the NAND operation between them, and you can get the equation of your borrow. Okay, so this is how we are drawing our full subtractor using only NAND gates.